Hello, grade 9s. Here's our first lesson on solving equations. Since they're the easiest ones, I call them one-step equations. So let's begin. So an equation looks like the following. We have a monomial with a monomial, and then there's an equal sign in between. So 3x equals negative 15. When we solve equations, we try to figure out the value of x. Now, x always wants to be by itself, right? Now, here's the equal sign first. So we divide that equation into a left side and a right side, where the equal sign is kind of like the dividing line. Now, x wants to be by itself. In order to get x by itself, we want to do the opposite of what's being done to it. So in this case, 3x means there's a times 3, or multiplying 3. We want to do the opposite of that, which is divide 3. And now what happens when you divide x by 3, these 3's basically, 3 divided by 3 is 1, so that it basically cancels out and the x becomes all by itself, right? But in algebra, whatever we do to one side, we have to do to the other. So if we divided the left side by 3, we have to divide the right side by 3. And so we're left with x all by itself and equal to negative 15 divided 3, which is negative 5. And there we have it. We've solved x. X is all by itself. Okay, that's how you do it. In this case, here we have an equation. Negative x divided 3 equals 6. There's the equals. There's the left. There's the right. X is negative, and it wants to be by itself, so it's divided by 3. We do the opposite, which is times by 3. When you divide 3 and times 3, basically those two operations, those two numbers get canceled out because the answer is 1. So negative x is by itself. But whatever we do to one side, we do to the other. So if I multiply that by 3, I multiply that by 3. So we have negative x is equal to 18. Now when we solve for x, that's just it, not negative x. We want to solve for x. So I have to make this opposite. So the opposite of negative x is x. But if I've made this opposite, whatever I do to one side, I do to the other. So I have to make this opposite. So that's negative 18. And there is the value of x, negative 18. Basically, this negative kind of comes over to this side. Here is a little equation, 2x equals to 3/4. I'm going to show, there's many ways to do it, but I've show a little trick in class that works and makes things a little bit easier. So it's called cross multiplying. So underneath the 2x, I place a 1 under there, and now I have a fraction equal to another fraction. What you do is you connect numerator to this denominator over here on this side, and numerator over to this denominator on that side. And now we multiply the two that are touching, the two monomials that touch. Always start with the one that has the x. So 2x times 4, we multiply it and write that answer, 8x. And now we multiply 1 times 3, the answer is 3, and we put an equal sign between, and you can see how easy this is. This is a one-step equation. So x wants to be by itself, we divide both sides by 8. Do the opposite of times, which is divide. Whatever we do to one, we do to the other. This cancels out the 8s, so we're left with x all by itself equal to 3/8, and that's a fraction, and that can stay because it is in lowest terms. We may want to write it as a decimal, and how you do that is divide top by bottom, 3 divide 8, and that would give you your decimal 0.375. And it's totally fine leaving it as a fraction. In fact, like it's preferred for me because I know how much students need to work on their fractions. So 3/8 is good. Okay, so now that we know cross multiplying, we can do the same thing here. The only thing we look at is in this x over 3 equals 2/5, the negative is kind of odd on its own. I always tell students you always put that negative up with the numerator. So in fact, this question is x over 3 equals negative 2/5. Better to put it with the numerator, and now we can cross multiply top numerator with bottom denominator, numerator with denominator, and now we multiply the one with the x first. So 5 times x is 5x. And negative 2 times 3 is negative 6. And now x wants to be by itself, so we divide both sides by 5. Whatever we do to one side, do to the other. We cross out those 5 so that we get x is equal to, this is a fraction. We can leave it negative 6/5, or we can write that as what's called a mixed number. So that's 1 2/5, but it's negative, so it's negative 1 2/5. If we want to write that as a decimal, we go 2 divide 5, so it's negative 1.4. Either or, they're all good. Prefer fractions, but they work. And that's how you solve that one. Last example here we have is negative 2.5x is equal to negative 3.5. First off, we always tell students to not work with mixed numbers. We have to change these to improper. So we have to multiply this bottom number times this, so 2 times 2, and we add that one. So that's 5, and the negative will go up top. Even the x will go up top with the numerator. So we end up getting negative 5x, because the 5 we got from 2 times 2 add 1. We put the negative up with the 5, and the x goes with the 5, and the 2 stays the same. This bottom number, it'll always stay as a 2. So that's what we change that to, negative 5x over 2. Equals 2, this one here, we go 2 times 3, add 1. We get 7 on top, put that negative with the 7, keep the 2 on the bottom. And now it's cross multiplying time, right? So we can multiply those two and these two. And starting with the one with the negative 5x times 2, we get negative 10x. And that equals to negative 14. And now we want to get x by itself, so we divide both sides by negative 10. Do the opposite. Whatever we do to one side, do to the other. That cancels out that. So we are left with x equals to, this is a fraction. These negatives, negative divide negative, they basically cancel out. Two negatives divided cancel out. We're left with 14 over 10, which is a fraction that can be reduced if we divide these both by 2, 7 over 5. That's improper, so we make that 1 2/5. If we want to write that as a decimal, we divide 2 by 5, we get 1.4. So there's the answer. X is 1 2/5 or 1.4. Okay, and that's how we solve. These are the top 5 questions that you would see. I'm going to give you one more, and that is a word problem that you would use, where you would use a one-step equation. So here we go. So we have a problem that looks like this. The length of a football field is 137.2 meters. If a horse gallops at 13.4 meters per second across the field, how long will it take the horse to gallop the length of the field? This is a problem that involves the formula that we know as the speed formula. And we learned this in class, that speed is equal to distance divided by time. And so all we have to do is substitute the numbers that we know and put them into the formula. So in this case, the 137.2 meters across the field, that is a distance. And this number here, 13.4, that number is referring to meters per second. That is a speed. So what we're trying to figure out is how long the horse will take. So we do not know the time. So the time is the only variable that we do not know. So we're going to rewrite this equation, speed equals distance over time, substituting these numbers in. So we get speed is 13.4. That's equal to distance, which is 137.2. Divide that by time. Now we want to solve for t, and you notice that that is a one-step equation. We can cross multiply. If I put a 1 there, now I can touch numerator to denominator, and we start with the t, the variable. So 13.4 times t is 13.4t. That equals to 1 times 137.2, which is 137.2. Now t wants to be by itself, so we divide both sides by 13.4. And whatever I do to one side, do to the other. Cancel those out. And it looks like there's our answer, is t equals this divide this, which works out to be 10.2. And since it's time, it needs to be in the same time unit, which in this question was S stands for seconds. So that is seconds. So 10.2 seconds is the time it takes that horse to gallop across the field that is 137.2 meters. And there you have it. There is a problem. And I hope this video has helped you with one-step equations. Good luck in class.